Good evening, students. We'll start with the class. Next topic is starting today is relative velocity or relative velocity. Relative in the sense you are trying to relate one object velocity with respect to another one. So you can, for definition, it's like velocity of an object with respect to the observer. So there will always be someone called as the observer. We'll give you an example. Suppose now there is a person B. Now is suppose at rest. There is no just standing there, not moving at all. Now there's a bus, suppose, which is approaching towards him, and then just going by. Okay, the road. And there's a person A which is sitting here. And suppose the bus is moving fast, and it just goes. Okay, it just was standing there or either sitting there and just watching. Okay, so this one is at rest, is not moving at all, and the bus is moving. Now, if B is trying to look at A, irrespective of the bus. Okay, now whether the not looking at the bus, his eyes on, suppose this person A is looking at the person A. Now what will happen? He will see it like the person is coming, approaching, and then moving forward. So what will B see? B will see A is moving at a certain speed. But although the speed is of the bus, okay, still what as per the person, it will look like the person is also moving at 60 kilometers per hour. Okay, like a flash of a second. Suppose if the bus goes very fast, it looks like as though the person went with high speed. It's like even a person riding a bike. Okay, so it's like the person went at that much speed. Now, this is case one. Now, case two. Now, this person enters the bus. Suppose the bus is stopped, and suppose the person is there in the bus itself. Now, he is sitting here like this, and the bus is still moving at that much speed only. Okay, whichever way A is this side, doesn't matter. B came and sat next to A. Now B is trying to look at A. Now, as per that logic, now you went and you sat, suppose, next to another person inside. Can you feel that the person is running away from you in the bus at 60 kilometers per hour? No, definitely not. But here, when you were standing, you could see that the person was moving at 60 kilometers per hour. But when you went next to him and sat, even you picked up like the same speed as that person. So over here, what will happen? B will feel that A is not moving, or it means this A is at rest. So the definition of relative velocity is like what? It's like every time the situation changes, your velocity of another object will change as per the situation. Here, it look like A is moving at 60 kilometer, but over here it's like A is at 0 with respect to B. The B will think is not moving. So this is relative velocity. So now we'll see various cases and how to calculate the relative velocity. So this is only for your understanding point of view. You can just write and keep. If you're not understanding something, you ask, huh? It's pretty clear. This easy to understand the relation. You're just standing, the bus moved, the A also moved with it. Here, definitely when you're sitting next to the person, you feel that the person is at rest. He is not running away. This is the first like a problem. Now consider B is at rest. Looking at the diagram only later you will understand. So no need to waste time in writing the theory part. I'm just giving you directly the diagram form. Here B is at rest. And suppose there's a trolley. There's a person standing on that. And this trolley is moving at 10 meters per second. And A is at rest. A is not running on the trolley, okay? He is just standing at one place. Okay, or A, you can just, A is not moving on the trolley. Now we'll try to calculate the speeds with respect to both. When B is trying to look at A, what will be the speed? And when A is trying to look at B, what will be the speed? First, we'll calculate velocity of A with respect to B. Means we have to check what is the velocity of A with respect to B, with respect to whatever is there. Remember, with respect to B means B is trying to look at A. So B is the observer. So B is observing A. So we want to know what is the velocity of A according to, with respect means according to B. So let us try to see formula wise how to calculate. The velocity of A with respect to B, the formula is observer part will always be next. Okay, velocity of A with respect to B. So B is always observer. Observer will come this side. So the formula is V of A with respect to the ground. Okay, V of A with respect to the ground minus V of B with respect to ground. Always it will be respect to ground. Okay, we are checking now. You can write here and keep velocity of A with respect to ground and V of B is velocity of B with respect to ground. This is the formula. So let us calculate. Now, I told you A is not moving on the trolley. He doesn't have a different speed. A is not having any speed according to his own body. Now he's just standing on this. So he has taken up full speed now, the trolley speed. So if the trolley is moving at 10 meters per second, automatically you know that even he's standing there, he's not jumping out of the trolley. So he's just standing. So it's like sitting in the bus only. So even the person is also moving at 10 meters per second. So with respect to the ground, so whenever this person is at rest, not moving, so he is picking up the trolley speed. So at what speed the trolley is moving with respect to the ground? Definitely it is moving at 10 meters per second. So straight away velocity of A with respect to ground is same like of the trolley with respect to ground. So is picking up the trolley speed. That will be 10 meters per second. So directly we write it as 10. And at rest, can anyone tell me what will be the velocity of B with respect to ground? Is not moving at all. So what we have to take? Velocity of B?
0.
Yes, that will be 0. So velocity of A will be. So B can see that A is moving at a speed of 10 meters per second because the trolley is taking him at 10 meters per second. Although the person is not running at that, but he is having a support which is going at 10 meters per second. That is how you calculate. Now the next part will be ulta. Let's see velocity of B with respect to A. Now imagine this person is turned back and he's trying to look at B. So this will be observer is now who? B with respect to A. With respect to A will come this side now. So this fellow is the observer. This will be V. The same order. B first means B with respect to ground. A means A with respect. This part will anyways remain same. Now only difference here will be first will be velocity of B with respect to. So this one anyways VBG minus VBA. Now substitute and see how much I'll get. Now it will be reverse. First velocity of B have to substitute. That will be 0. This is by default minus as per the formula. And now velocity of A with respect to ground I told you is same. So VBA will be minus 10 meters per second. Any doubts in this calculation? You can ask. Now it's the second situation. Now this suppose person comes here. Or B and A, whichever way. Trolley is moving. A is at rest. B is also at rest. Like this means I'm keeping them fixed. They are not running away on the trolley. They are just simply standing or simply sitting. What is velocity? Calculate and then tell. Velocity of A with respect to B. Just have to add G in front. Just split this letters, put G and G, and middle sign is always minus. So can anyone tell me what is velocity of A with respect to ground? A will pick up the trolley's speed only, no? What is velocity of A with respect to ground? At what speed is A
10,
traveling?
10
Yes.
ms.
Yes. And B is also traveling at that speed only because he is also on the same trolley. So that's why relative velocity is 0. That is why they can both see each other as not moving. So whenever you sit next to your friend in the same bus, your friend is also moving at 60 and you are also moving at 60. So 60 minus 60 will give you 0. That's why you can see your friend is not moving and just sitting next to you. Okay, so even B with respect to A, if B is also trying to look at this, that will also be 10 minus 10 only. It would be 0. So both looking at each other, they will look like as if they are not moving. Okay, so in both cases, both look at each other as rest. Now next, third case. Suppose this is B moving at 20 meters per second. There's A who is moving at 10 meters per second. So we'll calculate both the velocities. First, velocity of A with respect to B, suppose. First, calculate velocity of A with respect to B. They are running, okay, both of them. A is running at 10 meters per second and B is running at 20 meters per second. So what is the velocity of A with respect to B? A with respect to ground minus velocity of B with respect to ground. How much are getting? Calculate and see.
-10.
Yes. The velocity of A with respect to ground, it is trying to run at 10 meters per second. And then this fellow is, so always check, okay, in this direction means they are running in the positive direction of x-axis. Later I'll give you one situation. Suppose if they are, one fellow is coming this side, then what sign to take? So as long as they are running in the positive direction of x-axis, you have to take positive this value. This minus is of not because this is minus 20. This minus is because of the formula. Otherwise, we are taking it as plus 21. Why is it minus? Just try to see. See, this fellow is trying to run fast. If you see, this fellow is running at 10 meters per second. This fellow's speed is slow, and this one's speed is fast. So at some point, what will happen? He's running fast means he will try to reach towards him. Okay, it's like he's running fast. So how can B look at A as though he's coming closer and closer towards him? If your friend is running in front of you and you are running at a very fast speed trying to catch your friend, so how you can see your friend? The friend is coming closer towards you. The distance is going on reducing. So it's like your friend is getting pulled behind. So when you try to look at this and you're running fast, the distance is coming closer. So it's like your friend is trying to get pulled towards you. You can see it that way towards him. So it's like getting pulled means it's like coming in the opposite direction. From this side, it is coming closer to you. So that's why it will be like minus 10. Practically, if you go to think, so it's like getting pulled. So it's like because for B, this is negative because for B it looks like as if A is getting pulled behind. Because he is running fast. So it come closer and closer towards. Now suppose velocity of B with respect to A. Now A is like turning behind and looking at this fellow. Okay, just turning his head and trying to look at B. So what will be the relative velocity? This one is 20 and this one is 10. So it will be 10 meters per second plus y. Now if you turn this side and just look, what is happening is trying to come closer. So which side is, it's like coming in the forward direction, it's coming closer towards the positive direction of x-axis. Okay, so for A, how it looks like positive because for A looks like B is coming forward towards him. So when A is trying to turn the side, so B is coming forward, coming closer towards him. So that's why it's plus 10. We just try to think practically. No one will ask you for that explanation. Just minus 10 plus 10 is sufficient. Any doubts in this calculation? You can ask. Next situation. Suppose if there's a train which is going at 10 meters per second, there is one more train on a different which is approaching at 30 meters per second. We will calculate first with respect to B. This is A, this is B. Then second one we'll calculate B with respect to A. Nothing much to think. The first let always come first with respect to this. So AG minus B with respect to ground is 10. Can anyone tell me what is velocity of B with respect to ground? What is the velocity of B with respect to ground? How much? Yeah. Yes, very good. Minus 30. Because this is negative direction of x. Therefore, minus 30 meters per second. If it's in the positive direction, always take plus. Now, this minus is of what? Of the formula. Now, this is minus 30. So, be careful here like this. Don't get confused. Already this is minus, so that's why I'll write plus. This minus is of the formula, and this fellow is because it is going the opposite direction. So minus of minus will give me plus 40 meters per second. The second part, velocity of B. Now this is simple. It will be only giving a different sign. Sorry. This will be 30 and then it will give me 40. So VBA will be VBG. So this is minus 30. This is minus already, and this anyways is plus because it is going the positive direction. So plus, we don't normally write plus because plus into minus will anyways give me minus. So that's minus 40 meters per second. A different condition. Suppose B is at rest. There's a trolley. Suppose no. There's a person standing here, and this person is also is moving. A is moving at 2 meters per second, and the trolley is also moving at 10 meters per second. Calculate relative velocity of A with respect to B. Now A is not sitting there. That A is also moving. Okay. As per the normal formula, what it will be is velocity of A with respect to B would be he is at rest. So velocity of A with respect to ground, velocity of B with respect to ground. Now, I want to know what is velocity of A with respect to ground. Now, if he was at rest, if he did not have any speed, then what it would have been? It would have been straight away of the trolley, because he would be just picking up the speed of the trolley. Now, he himself is having his own speed, so you cannot directly relate it to the ground. Okay, so in that case, we'll just keep this like this only. Whenever a person is moving itself on this, you don't write directly with respect to ground as 2, because this 2 is not with respect to ground. This 2 meters is with respect to the trolley. Is running on the trolley. Okay, and the trolley is with respect to ground is 10. So we'll keep it this much only. We don't know what is the value. This we know is 0. Now let us calculate with respect to ground how much it will be. If it was at rest, straight away answer would have been 10, because this fellows would be anyway 0. We'll see. So this is one part. The second part is to calculate velocity of A with respect to ground. For that, what we'll do is, we know that we'll try to calculate what is velocity of A with respect to trolley first. You can use the letter T there, because he is not directly with respect to ground. He is running on the trolley. So velocity of A with respect to trolley will see first. So as per the formula, I told you, just have to split the letters and put ground there. So velocity of A with respect to trolley would be VAG minus VT. So what is velocity of A with respect to trolley? Can anyone tell me? With respect to trolley, at how much is running? At which speed is running on the trolley?
2.
Velocity of A with respect is running on the trolley. So what is the this on the trolley? At what speed is A running? I'm not asking what is velocity of the trolley with respect to ground. I'm asking A with respect to trolley. So definitely it will be 2, because A is running on the trolley. So this is 2. This ground I don't know. With respect directly to the ground, we have to calculate. This is minus. Now what is velocity of T, the trolley with respect to ground? With respect to ground is running at 10 meters. So this is at what speed? Okay, this is velocity at which trolley is moving. And this is velocity at which A is moving on the trolley. So now bring this minus 10 this side. Minus 10 if you bring that will be plus 10. 12 with respect to ground. Now take this equation and substitute. Write the equation again. So put 12 here. So velocity of A with respect to B is 12 meters per second. So this part which we did not know, we got from here, so substitute it there. So it's like how the trolley was running only at 12, at 10, plus he is also running. So if they are in the same direction, no, it's like this speed plus this speed. So it's like 12. And if they were normally in the opposite direction, always the speed will get minused. We are running both in the same direction, and then it could be added. Because the trolley itself is taking him at 10, plus he is adding his 2 meters to that own speed. So that's why it becomes 12. Any doubts in this? You can ask. Huh? Next condition is there's a car. The person is sitting in the car at rest, fixed. This person is B. Now this person is in the opposite direction. This is going this side. This car is moving at 20 meters per second. Find relative velocity of A with respect to I have to calculate first, right? VAB is what? V. This is what we have to calculate. This is what we have to calculate. Now again, when both are moving, you don't know exactly. First we'll have to calculate this separately. So you have to keep it like that only. We don't know what is velocity of A with respect to ground. Only if it was rest, at rest, directly you can take it as 10. And now when this fellow is moving, leave it that much only. And now this fellow. This is directly you can take 20 because he is at rest. So he is having the same speed as the car. So there is nothing to calculate. Now if this fellow was moving in the car, then it would have been a different thing. But now he's at rest. So automatically his velocity of B with respect to ground is same as that of the car. That is 20. So we don't know this part. So keep it that much only. Now always whenever both the things are moving, calculate with that person with respect to the trolley. This is first part. Second, now velocity of A with respect to the trolley. V. How much are getting? Velocity of A with respect to ground. How much did y'all get?
13.
Yes. Because over here, just see, velocity of A with respect to trolley, how much it is? Is going in the opposite direction. See right here, negative direction of x-axis. So this has to be taken as -3. If he was running this side, it would have been plus, but he's running in the opposite direction of x-axis. That is minus. This we have to calculate. This is by this. It is going the positive direction, so that will be anyways 10. So -10 you bring this sign, it will become plus. So 7 you will get as the velocity of A with respect to ground. I told you anytime if they are going in the opposite direction, their velocities will always get minus. Then the same direction, then they will get added. Now put it here. So VAB is VAG minus VB. That was how much? 20. And this is 7. Answer is minus 13 meters per second. Anyone who has still not understood how this is working? Like suppose similar situation, try just to add one more thing. There's a person, same one, B is at rest. The car is moving at 20 meters per second. Now there comes a monkey. I can't do, I don't know what symbol to put for monkey. So however you all want, you'll just keep it there. The monkey. And he is moving this side at 2 meters per second. On the car. And then there's a trolley, same like the previous one. Only extra this fellow is there. He is moving at 3 meters per second. This is 10 meters per second. Find velocity of monkey with respect to A. Just use the letters and go on checking. Okay, so velocity of monkey with respect to A. My velocity of monkey with respect to A. So as per the formula, this will be mg minus A. In the previous problem, same thing it is, no? Nothing has changed. Velocity of A with respect to ground. So from the previous problem only I used this value. How much we had got VAG as VAG from previous problem. So if that was not there, then you have to sit and calculate. Okay, velocity of A with respect to ground, if we had to check. Then we have to check with velocity of A with respect to trolley. That would be -3 plus 10, because this is going in the opposite direction and this is going in the plus direction. So minus, okay, 10 minus 3 would give me 7. So from previous problem, only I take the value VAG is 7. We don't know what is VMG of monkey with respect to ground, because the monkey is also moving. It's understood looking at the diagram only. Both are in the same direction. Actually, velocity of monkey with respect to ground would be, if they are both in the same direction, I told you always add the velocity. So you can actually directly write, but I don't know if your teachers will give you marks, so you can show the calculation then separately. Otherwise, you know it's 22. 2 plus this. Still, this we know 7. Now we'll calculate what is VMG. So for that, what I'll have to do, we'll have to calculate the velocity of monkey with respect to car first. Because monkey is on the car, is not on the ground. The car is on the ground. Monkey's velocity with respect to car is 2. This we have to calculate. And this is minus 20. Now bring this minus 20 this side. This will be plus 2. So velocity of the monkey with respect to ground is 2 plus 20, that is 22. And now put this value here. You just have to know what you need at the end. Accordingly, you have to find a value. So what is VMA? VMA is nothing but VMG minus 7. So what you got, VMG as 22 minus 7. So 15 meters per second is the relative velocity of monkey with respect to A. You just have to follow the letter order. That's it. Any doubts in this, you can ask. Next question. A police is running at speed of, or you can say directly at 20 meters per second after a thief who is running at 10 meters per second. Distance between them is 100 meters. Find the time at which the police will catch the thief. So calculate distance covered by police and the thief. So police is running at 20 meters per second after thief who is running at 10 meters, who is running little slow. Then after running, at some point definitely the police will reach near the thief. Currently, when they are running at this speed, the distance between them was 100 meters. So find a time. After certain time, he will catch. He is not catching at that moment only. After covering more distance, okay, then they will this police will catch the thief. So find a time at which the police will catch the thief. Also, you have to calculate how much total distance he had to cover. Right now, he is covering 100 meters. After that, also how much he has to cover, you have to calculate. So it's like the police is here, the thief is supposed here. He is running at 20 meters per second, running at 10 meters per second. Hundred meters, and then you know that after running, at some point they will be both at the same place. So we have to calculate that particular time. And then how much will be the total distance the police will cover from here to here, and how much will be the total distance the thief will cover from here to here. Now, whenever you see speed, distance, and all, you know that speed is nothing but distance upon time. So we'll be using that formula later on. So first we'll just find what is the relative velocity between them. So relative velocity of police with respect to thief, we'll calculate. Thief with respect to ground. So velocity of police is 20. Velocity of thief will be 10. This 10 meter per second is the relative velocity. So whenever you're solving relative velocity problems, no, so velocity we are using the word. We're not using the word speed. Okay, because your direction also matters. Why we are using the word velocity? Because if this is in the opposite direction, then automatically your value signs are changing. We are not only putting the magnitude, we are also looking at the directions also at which they are running. Okay, so that's why we use the word velocity and not speed. Velocity means both magnitude as well as direction. So we know that this is the formula for speed. Speed is distance upon time. But what is the formula for velocity? Nothing but same thing. Instead of distance, we have to just use the word displacement upon time. So after this is they have not asked me only to find a relative velocity. They've asked me to find a time and distance. So that's why I have to further solve this problem. So we know that velocity is nothing but displacement Displacement is same as distance. So right now that's the shortest distance between them. Displacement is what? The shortest distance between the police and the thief. Right now it is 100. So this is nothing but your relative displacement. You want to know? This will be a relative velocity. How much relative velocity you got? 10. How much is the displacement? 100. Time is what we have to calculate. You have to remember that formula. Velocity is always displacement upon time. So time you take up, 10 will come down. So that will give you. You can use the word t also. Okay, let t be the time. Instead of this, you can just use the word letter t. However you want. 10 seconds. How we know it is seconds? The units which are used are meters per second. The time will always be in terms of seconds. Okay. Time we got the first question. Next question is distance covered by police. Again, same formula. Velocity is displacement upon time. I want to calculate the displacement. So time will go up. At what velocity is the police running? So this is velocity of the police. This time is this 10 seconds. So he is running at 20 because we are calculating for the police. This is 10. So distance he covers till he reaches the thief to catch him is 200 meters. This is distance covered by the police. Same way, calculate distance covered by thief. Formula will always remain same. Displacement upon time. Only difference here, we have to put velocity of the thief there now. Time anyways is 10 seconds. Because at 10 seconds, they will meet each other after running. So this 10, this is velocity into time. He is running at 10. This is 10 seconds, 100 meters. So it's like he ran for 100, then 100, and then they met. This was police, this was thief. The police total distance was 200. The thief's distance was 100. And the total time which took till to reach was 10 seconds. So the distance covered by the thief was 100 meters. So we calculated all the values. Time we calculated, distance covered by the police, distance covered by the thief. Any doubts in this? Cannot. In the next class, no, this this all mixed problems because now we are doing topic wise. Then what happens in the paper when you'll get mixed problems? Then you'll get confused. So anyways, now I'm doing topic wise questions and then together we'll solve the next class all kinds of problems. So now these are based on kinematic equations. So the kinematic equations which you need to know are three of them. This you have to know at any cost. All the three. U plus AT. Second formula is UT plus half AT square. Third one is V square is equal to U square plus 2A. These are the three things. So what does this mean? I'll give you what are the letters here. S is the distance. T is definitely time. A is definitely acceleration. Now what is this U and V? U and V are both velocities. But now U is always your initial velocity and V is always your final velocity. This is like a start point. This is like an end point. Write this. Whenever I say a car at rest starts moving at 120 kilometer per hour. A car at rest starts moving at 120 kilometer per hour. So what it means is rest means here this fellow is at rest. Then it starts and picks up 120 kilometer per hour. So at rest, remember that you are always starting with 0 as your velocity. Zero means here U is 0 because this is initial. And here V is 120. This we don't know whether it is this not stopping. Okay, this is definitely not stopping, it is moving. So this is kind of like a final. So always any problem will always have initial as well as final. So initial definitely you know is 0. So the other one which speed you have is automatically becoming a final. So that's a 120. And in this case, whenever a car from rest starts moving, it's always called as accelerating. The car is accelerating because obviously if you're starting from 0 and then increasing, it means you're accelerating. Now look at this situation, the second one. Or is brought to rest. So a stop, or sometimes also called as rest. Yeah, it stops. So now what is happening? The car is moving and then brought to a stop or a rest. So here it is stopping. So this is the final point. At starting point, what you obviously this is the final point means here v is 0. The final velocity is 0. And you have to take as 120. Remember that. So that becomes the initial. Even though it is moving, so you have to take it by default as a initial. Now don't try to think, oh, it must have started at some point, so I'll take u as 0. No, they're saying already moving, so this is considered to be a initial. Stop means final. If we think the car is starting and then ending, if they specify the car started and then ended, then both will be 0. And there's no point also calculating that. Both are 0. Okay, so this has to be. In this case, now what is happening? Now 120, so you have to bring the speed of that car to 0. So this is always called as retarding. Okay, so you will hear the word car is retarding, which also means as deaccelerating. The letter which is used for both cases is A only. Only thing here you will get answer negative, here it will be positive. Don't put D for retarding or deaccelerating. The letter will remain as acceleration only, A. Retarding means its only thing is the acceleration is reducing. So the English word used for reducing of acceleration is retarding or deaccelerating. Okay, so this is the conditions. Accordingly, then we have to apply. Now there are proofs based on this. We'll prove all the three formulas. First one. So that starting part will be given in your notebook in the college also. That much I'm not stressing. Let V be the initial velocity, U be the this V will be the final velocity, U is the initial velocity, A is the acceleration, T is the time, which I already gave you in the formula. So now, like something has started from here, U, and it has traveled for a certain time T, and then that will be a V. So you take as, you don't take 0, you just take as U, and this is your initial, and this is your final. And this is the time taken. Start with the proof. So you know that what is acceleration? Acceleration is nothing but rate in change in velocity per unit time. This is what we know as per the definition. Acceleration is nothing but rate in change in velocity per unit time. So in terms of formula, obviously we have already studied nothing but delta V upon delta T. So what as per this is always V final minus V initial, okay, upon your total whatever T final minus T initial. So A will be nothing but So what is the final velocity I've assumed it to be? V. What is the initial velocity I've assumed it to be? U. And what is the total time taken? It's like t minus 0 from here to initial to final, whatever is the time. So t minus 0 anyways will be t. So we have just used the acceleration formula, that is final minus initial velocity upon your time. And now what we have to do is just try to get this equation. So what I'll do, bring t up. This is in the denominator. If you take it up, it will become multiplication. So this will be a into t, and then u is minus. If I bring this side, it will become plus. So it's the same thing. Just write v is u plus. So whether I write this side, this side doesn't matter. It's like writing 2 equals to x or x equals to 2. So u plus at is equals to v. So we got the answer. That's the proof. Any doubts in this? Did not understand? You cannot. Then the second proof. This is equal to ut plus half at square. Now we'll consider this diagram over here. So this is your velocity, and this is your time. Now consider, we will not start from 0. Suppose a person is starting somewhere here and going this side and reaching at this point. Okay, so as per that, what will happen? This is velocity. So this will be your initial velocity u, and after going is here. So if I want to calculate the final velocity, what I'll do, we'll see at what point it has stopped. Just draw like this. This will be your final velocity. At this point, it stopped. This is your initial speed, and then it goes your stop. So that will be your final speed. Okay, so we have this S means there's a displacement. So remember, if I want to calculate displacement under velocity versus time graph, then displacement is nothing but area under the curve of velocity versus time graph. Here it might not be a curve. Sometimes see the velocity can go like this also. Okay, so that's why sometimes it can be like this. So whatever is area under that, okay, area under the curve of velocity versus time graph, this area if you calculate will always give you the distance or the displacement, how much the person has distance he has covered. So although now the word curve is been used, it's a straight line. So anyways, it's whether it's straight line or curve, it's like whatever is the graph under that, whatever is the area will be your displacement. So if I try to shade this, so this is what I have to calculate. Area of this part. That will give me the displacement. So what is the formula for displacement? Area under the curve of velocity versus time graph. Now if you see, it looks like a trapezium. It's not a parallelogram, nor it is a rectangle, nor it's some triangle, but it's a trapezium. So difficult to find area for trapezium. So what I'll do, I'll split this region into two parts. If I just put a line like this, I get one triangle and I get one rectangle. It's easy to always calculate area of a triangle and area of a rectangle. So that's why I make two parts of this area. Finally, I want the total area, but this and this I'll calculate separate and then add. So we'll write some names for that. Let this letter be B. Just this is 0. O, you can put A, B, C, and D. If you are using different letters also, no problem. Whichever you want. And this from here to here is your total time. It's always time versus velocity graph. No? Now we'll calculate the displacement. So displacement is area under the this. So it will be what? Area of triangle plus area of rectangle. So which is that area of triangle? Area of triangle DBC or CBD, whichever you want to write, plus what is the rectangle? OACB or OBCA. I want areas of both the figures, triangle as well as the rectangle. Obviously, area of triangle everybody knows it is half into base into height. So half, what is the base of the triangle? BC. And what is the height? CD. Area of the rectangle, any one will take. Length into breadth. So length is OA and breadth is OB. Now we have to substitute. So quickly we'll see what all other this. BC is how much? BC is same as OA, same length it is. So which is nothing but equals to T. From here to here it is T. Then what else we need? BC we got, OA we got, CD and OB. What is OB? From here to here it is U. From here to here it is U. It's like if this number was 5, consider U was 5. So what distance this would have been? 0 to 5 would have been 5 units. Okay, if U was 5, we would take it as 5. But now it is U, so we'll take it as U1. OB is U, this much distance. And consider this was 20. Okay, this was 20. So what is CD? CD is nothing but, I want this distance, this much. So it would have been considered this was 20 and this would be 5. So what I would do, 20 minus 5 would give me 15. So nothing but CD is nothing but V minus U in terms of letters. I want only this distance. So it's like whole V minus this U. This much part I will get. So now substitute all the letters over here. So half BC is how much T, CD is how much V minus U. plus OA is how much? T. OB is how much? U. So how much we'll get? So instead of writing multiplication, I'll just write it like this. So mark this as equation 1. But still I have not got same like the proof. The answer should look exactly like in the proof, whatever the equation is. That it should look half 80 square plus ut. We have still not got this part. This we got. Now we'll try to do some substitutions over here. From the first proof itself, we studied that what is acceleration. Acceleration is nothing but final velocity minus initial velocity upon time. Acceleration is final minus initial upon time. So what is value of v minus u? T if you take this side. Okay. T if you take up. So mark this as equation 2. Now put value of v minus u. What is the value of v minus u? 80. From equation 2 in equation 1. So instead of v minus u, what I'll put? 80. S will be half. It will be 80. T into T will give me T square. So instead of v minus u, I just put 80 here. And then I got the answer. So only part this you have to remember, that acceleration is final velocity minus initial upon time. So this is your second proof. Now the third one. Any difficulties in this, you can ask. Third proof is v square is u square plus 2a. I'll just extend the class a little bit. So next class I just want to finish the chapter. So first and second equation we know. What is the first equation? Just now we saw that a is v minus u upon t. Okay. Acceleration is v minus u upon t. So what will be t if I want to know time? Time will be nothing but acceleration will come down. So mark this as equation 1. And from the previous proof, we also know that S is nothing but ut plus half at square. Mark this as equation 2. This we already know from the previous proof. This also we already know. A is final minus initial upon time. So what you do? Put value of t from equation 1 in equation 2. So wherever there is t, put this value. wherever is t, because I don't want this t value. I want everything in the v, a and s. I don't want t. So I'll try to get rid of this t. So I'll put the value. So u, instead of t, I'll put this v minus u upon a. V minus u upon a, the whole square. So there's a square term, so this square term will apply to both the terms. So don't simply cancel on, there's a square, there's a bracket. So v minus u the whole square upon a square. Square I gave to both the terms. And this many make mistake, v minus u the whole square, they write it as v square minus u square. A minus b the whole square is not a square minus b square. You get a big zero. It is a square minus 2ab plus b square. And now once it is out of the bracket, you can cancel one of the a. Now a you can separate to both the terms. Apply the formula a minus b the whole square. So it will be a square minus 2ab plus b square. Now a you can separate to all the terms. And this you can multiply inside now. So this will be uv upon a, and u into u will give me u square upon a. Then this a if we're separating to all, and this half also will get multiplied to everyone. So this will be v square upon 2a, then 2vu upon this 2a. 2 applies to all the terms because there's a bracket. Same way a also applies to all the terms. U square upon a, because 2 into a will give me 2a. So over here 2 and 2 will cancel. Now similar terms you bring together. Uv upon a, after cancelling this will become minus uv upon a. This fellow and this fellow are same. U square upon a plus u square upon 2a. This will be last you can keep. What is going to happen? This and this will cancel. vu upon a, and this is because u into v same as v u into v, v into u. V into u can also be written as u into v. So both are same term, so they will cancel. Now what is common between these two terms? U square upon a is common, so just remove out u square upon a common. So what will remain here? Minus 1 between these two terms, and here half will remain. U square upon a I've taken out, and now cross multiply. We will get it as minus half. Minus 2 plus 1 upon 2 is minus 1 by 2. You can simplify in your own ways also, by just directly also, no issues. As long as you're getting the same answer. So this will be minus u square upon a into 2 is 2a, and v square upon 2. And both the places denominator is same. So I'll make it common again. Now this 2a I'll take up. So 2a into s will give me 2a. And minus u square if I bring this side, it will become plus. And that's exactly what we wanted. V square I'm writing this side, rest all I'm writing this. So this is our third proof. Anyone not understood? Okay. Now we'll solve one problem and then we'll stop. The question is, car moving on a straight highway with speed of 126 kilometers per hour is brought to rest or brought to a stop within a distance of 200 meters. What is the retardation of the car and how long does it take to stop? A car is moving on a straight highway with a speed of 126 kilometers per hour. So it's like moving and then it is stopping. So this is starting in 126 kilometers per hour. Total distance covered is from here to here 200 meters. So distance means always we'll write or whatever has been given. So it is starting here. Initial means obviously 126. Stopping means velocity is 0. So final velocity will be 0. So write all the data. U is 126 kilometer per hour. V is 0. Distance is, now retardation has been asked. So even if they ask you what is retardation, still I told you have to use the letter A only. Only thing answer will get in terms negative. And we don't know what is the time. How long means time. How long does it take to reach the stop? So the three formulae which we know is ut plus half at square or v square is equal to u square plus 2as. These are the three formulae. Now one more thing to notice, remember even during exam, check for the units first. This is given in kilometer per hour and this is in terms of meters. If this was given meter per second, then it would have been good. It would have been in the same range, meters. Now this is in terms of kilometers, this is in terms of meters. Always check for that first. So I have to first convert it into meters per second. So U is how much? 126 kilometer per hour, but I want it in terms of meters. So remember, for kilometer to hour conversion, kilometers into meters. So how many kilometers? 1 kilometer equals to 1000 meters. So always 1000 it will be. 1 hour will be what? 60 minutes per second. I want always meter per second. This is minutes, and then again 60 seconds. So this is a fixed conversion from kilometer per hour to meters per second. This will be meters per second. So if they had given you 60 kilometers per hour, this value will remain fixed. Whatever is this will change as per the question. But for the conversion, this is fixed. You can just, if you are finding difficult, you can just by heart also increase 1000 upon 60 into 60. And then you can calculate. This will cancel. So it's like multiplying it with 10 by 36. After calculating, it will, this 126 upon 36 will give you 10.5, 3.5 into 10. So we will get it as 35 meters per second. So that's your U. If you don't convert and directly take 126 in the problem, 0, nothing you will get. If this was also in terms of kilometers, then okay. But if there's a change, you have to convert. Now, what all we have to calculate? We have to calculate acceleration, we have to calculate time. Now, which of the three formulae to use again? Look at this. You would go for the first one. V I know, U I know. Do I know A and T? Both I don't know. Any equation, two things I don't know, I can never find. Okay? Like only one should be unknown. Here, both of them I don't know. Over here, this I know, this I know. Again, T I also I don't know, A also I don't know. So I can't calculate. Over here, U I know, this I know. Distance also I know, as is given to me, 200 meters. Only one I don't know. So definitely I have to use this formula. To check what is been given and what you have to find. Use for this, you will be stuck. A also you won't know and T also you won't. So use this formula, V square is equal to U square plus 2AS. And then V square will be 0 square. This is 35 square. A we have to calculate. S is how much? 200. Now this will give you 0. Best option is not to like square it and waste time. Keep it as 35 square only. Okay. This will give you 400. 2 into 200. Now this whole term you take it on the other side. Now what you do instead of writing, you can simply write it as 2 times square as 35 into 35, and this you bring down as 400. Because this multiplication, it will come down. It becomes easier to simplify. So then what will happen? 5 7s are 35, 5 8s are 40, and then 0. So 5 7s are 35. So you save time instead of squaring and then again trying to simplify. Okay. So 5 1s are 5, 5 6 are 30. So what is your A? Minus 49 upon 16. If you calculate, you get it as minus 3.06 meter per second square. Write the units compulsorily. Unit of acceleration is meter per second square. So one part you got. acceleration you got. Now time is left. Now you can use any of the equations, first or second, doesn't matter, because now you already know what is your A. So I'll use the first equation. See, that's why we got negative. It was what, retarding. Okay. V is what? 0. U is 35. Now you have a choice. You want to put decimals? See, if you try to put decimal, no, just see, it will just get complicated. I'll show you both the ways. This is multiplication, so I cannot add these two numbers. This is minus, so you'll get like this, 35 minus 3.060. So you cannot add it to here. So first what you'll do, take 35 on the other side. And then what is going to happen is, now if you have, now you all are answering online and calculators you all are using, that's a different thing. But for exams, again you are stuck with decimal points to calculate. It's a big number. So avoid like this type. If you have, what you do, already you had a fraction here. So instead of doing this method, you can still do if you're okay with calculation. Otherwise, use the same formula, V is equal to U plus 80. But while substituting, you know, A is nothing but minus 49 upon 16. So that one I leave. This will be A is minus 49 upon 16. So what will happen? This 35 will go that side. And now take this here. So division will always become multiplication. And this will come down. That will be 3. So this and this will cancel. 7 5s are 35. 7 7s are 49. So this becomes very easy to calculate. So you'll get it as 80 by 7. Time you will never get negative. If you are getting time as negative, means something is gone wrong. And 7 1s are 7. 7 1s are 7. 3 7 4s are 28. 3, something like this will get. So it becomes very easy to calculate. So that's the time and that's the acceleration. So what will write a final statement? Therefore, car is retarding at. Don't write again negative. Retarding means already in minus. Retarding means already it's minus. Again, don't put minus. And the time taken is 11 seconds to stop. Let's stop for whatever is the question. For the car to stop. Okay. So I'll stop here.